Evening, everybody, and welcome to BSides Las Vegas Proving Ground. This talk, Securing Fast and Furious DevOps Pipelines by Abdessamad. A few announcements before we begin. We would like to thank our sponsors, especially our Inner Circle sponsor, Critical Stack and Belly Mail, and our stellar sponsor, Silence, Microsoft, and Robinhood. It is their support, along with our sponsors, donors, and volunteers, that make this event possible. These talks are being streamed live, and as a courtesy to our speakers and audience, we ask that you check to make sure your cell phones are set to silent. If you have a question, use the audience microphone so YouTube can hear you. Please raise your hand and I'll bring it over. Okay, let's get started.
Okay, so first, I'm gonna ask you to fasten your seatbelt because this talk is about securing fast and furious DevOps pipelines. And I thought that would be interesting to start by sharing a personal story that I hope to resonate with many of you. So the name will be unnamed, but it goes to something like this. So we are about to release our new application, but we decide to go through penetration tests in order to see if we have some serious issue that we need to fix first. But unfortunately, the penetration tester was able to breach our application by exploiting an outdated version of a specific library. So, to the dev team, could you please update the library if you want to 6 to the latest version? And the answer is no. Sorry, that would take weeks. We don't have the resource to do that. And we have to ask how this happened. So in this particular case, it was a dependency which is tightly related to other dependencies and used by hundreds of services. Some of them have not been updated since years, which means updating the library means updating a huge part of the application, which is frankly a time-consuming task. So the main problem is we wish to fix this issue, but it is too late and too complicated to fix at this level and at this stage. And this is mainly one of the many situations where security automation can really help us. Because what we want is early feedback about this kind of security issue. We'll see in the incoming slide how we can do that. And we don't want to rely anymore on manual security activities because they are not designed to operate at Hink scale. And they are just bottlenecks for bug fixes and new features to get to production. And with the push for faster and furious DevOps deployments, the bottleneck is tightening even more. And maybe we don't want to get in this kind of situation where we have to accept the risk because, as you may know, the business goals always win versus security needs. And also we are maybe tired of having the same basic issue again and again after each penetration test. So especially these low-hanging fruits that can be sometimes identified by script kiddies and exploited using automated tools. So we don't have it to happen again and again. So this talk will be mainly how can we avoid this kind of situation, and we will see how to reuse the same concepts and tools that are already used by DevOps teams in order to secure and keep up or catch up with the fast CI/CD pipelines. So let's see if we're gonna catch them. Okay, so briefly my background. So I'm from Serious Advisory, so a consulting firm at Paris, but I work as an application security lead at Amundi, which is an asset management company. I'm also certified, offensive security certified professional. I also did a lot of contribution to the OWASP community, mainly to the mobile security project. And the tool, I also shared the tool that we are going to see in this presentation. You can reach me at Twitter or LinkedIn. So as you may notice, my main background is about offensive security, but moving to my actual role as an application security lead, I figured out that as a penetration tester or as an offensive guy, the service that I want to provide to my client, or I did provide to my clients, was all about break-in stuff and offensive security. So at some point, I figured out that this doesn't really help my customers to improve the security posture of their applications. So by moving to this more defensive role, I consider it as an opportunity to work closely with developers in order to figure out how we can embed security at hand scale with a developer-friendly manner. Okay, so let's take a look first at what is the most important challenges that we may face when we want to automate security testing. So the first one is the implementation speed. So so as you may know, the development these days are completely moving to rapid agile approaches and shipping things more frequently. And as we discussed before, manual security check just continue to be untenable as a way of working with modern teams. They are not even designed to work at hand scale. And then we have integrations, very important. So for the security team, we need to admit that the dev teams have already their own process and tools, for example, to manage the workload and automate the building and the unit testing of their application. So the security team need to take on these tools and process and figure out how to integrate in all of these. Also, we have the ease of use. So the solution that I want to provide, it must be something simple to use and inject in any kind of development software supply chain. And then we have accuracy. So one of the big no-no here for security tooling is, as you may know, is false positives. So we need to figure out how to manage these false positives and how to enhance the capabilities of our scanning engine in order to reduce the false positive. Also communication. So we have to provide key metrics about first the ongoing scanning activities, but also the security level of our application through the whole development lifecycle. And finally, we have portability. So the solution that I want to provide, I want it to work either on Jenkins, on Travis, GitLab, or any CI/CD engine. So what kind of security testing tools that we can use inside our organization? So there is mainly 4 categories. The first one is software composition analysis. So it helps us to track the dependencies that we are using inside our application. For example, it's really helpful to know what are the dependencies that we are using that have already some known vulnerabilities. If it's the case, how severe they are. And this basic control can really be helpful in the situation or the case we discussed at the beginning of this presentation. And then we have dynamic scans, which is a kind of gray and box testing methodology. So it tries to simulate a live attacks by sending malicious HTTP requests and analyzing the response of the application. And then we have SAS analysis, which take as an input the source code of the application or the binaries, and it tries to build what we call intermediate code representation, like data flow or call flow, like the data flow or callback flow. And then it checks all possible execution paths in order to identify, for example, some common weakness related to input validation, broken cryptography, and so on. And then we finally have the interactive testing methodology or tools, which is considered as the next new big thing for automated security testing. So the idea, it tries to combine the 3 first technology in order to provide more accurate results. And they have some kind of agents deployed on the QA servers in order to monitor the execution or the runtime of the application and correlate results from these scanners in order to improve the coverage of the security testing tool. Of course, there is some cons and advantage of each technologies. For example, in terms of actionability, developers tend to use or prefer to use SaaS tools because it points right on where they need to fix the issue, so it's easy for them. But in terms of relevance, it may generate a lot of false positives. And then we have dynamic application security testing, which in terms of relevance, it provides more accurate results because it focuses on the front end of the application. So, and the false positive rates is very low compared to static analysis. But the problem with this kind of tools is in terms of actionabilities. So it's the only information it provides about each issue. It is just the URL where the vulnerability was identified. So the developer needs to figure out by himself where is the code implicated in each vulnerability, which can be an overwhelming task. And finally, we have the interactive application security testing, which tries to combine the advantage of each one of these solutions in order to provide more relevance and more actionable results to the developers. And in case you are hesitating between which tool to deploy inside your organization, you can use this awesome open source project. It's called OWASP benchmark tool. So basically what it did, it tried to make a kind of benchmark between different static or security testing tools based on the scanning results, and it provides you it can tell you which tool, which the most convenient tool for your company and the context of your organization. So you can check the online documentation about how to use this tool, and in order to figure out, as I said, what tool fits your organization. So let's move on to the most interesting part, where we will see how to integrate all these security testing tools inside an existing CI/CD pipeline. So this was my first implementation. It's a very basic one. So you just have to, for example, if you want to run dynamic security scan using ZAP, you just have to install a plugin inside the Jenkins, and it will communicate with your ZAP instance, and you can add as a build step the scanning activity. So the takeaways of this first solution. So the first one, it works, and it is a very important takeaway, I will say, and it's something very easy to begin with and operate. But the main problem is, suppose that you have some build agents for your Jenkins or GitLab CI/CD engine. So you don't want to occupy a build agent by scanning, for example, an OWASP scanning process, because it may break the velocity of your CI/CD engine, and developers may end up being unable to build their own applications. So that's the first problem. The second is portability. So suppose that your dev team decide one day to move to a complete different CI/CD engine, or maybe they just want to do some upgrades. So for the security team, you have to reconfigure everything from scratch, which can be a very overwhelming task. So I solved the first problem by wrapping my security scanners into some Docker images. So this solution was even more easier than the first one. It is just a Docker run command that you have to add to your Jenkins file, for example, in order to run an OWASP ZAP scan. So the good thing is, the first one is we solved the portability issue. So we just have to build and configure our security image, and we can use it basically from everywhere. And also, it was more easier than the first solution. We don't have to install anything inside our CI/CD engine. It is just a Docker run command. But when we have 2 or 3 containers, it is not something difficult to manage. But when you start moving to, or when you have multiple dev teams with multiple scanners, the management of your Docker image becomes something very difficult. And in general, when you are operating at Inc scale, the orchestration of your scanners and your images become essential. So I solved this. So we start to think on a more convenient solution in order to solve these two problems. And that's where we move to a Docker containers or a scanners orchestration solution. So the main goal was to solve the performance issue by moving to a container-based or a containers orchestration solution. So this is the final architecture that we came up with. And basically,
Sousaphone? Am I in the wrong room? Did you make an outrageous speaker request for a DeLorean and Sousaphone? Nope.
I don't get it.
I'm in the wrong spot.
Okay. Okay, perfect. So this was the final architecture that we came up with, and which can be simplified as follow. So I will try to explain each component of this solution. So first we have the scanners orchestration layer, which can be used to distribute the scanning workload through the Kubernetes clusters. So, and the only thing that your CI/CD engine does effectively, it's just schedule a pod with a microservice into it, which will handle scanning activities. And then we have the scanner registry. So we used our internal registry to store our security images. The purpose was to unify how we use and we run our security toolings. And this was very helpful for the security teams because it allows us to continue to make changes to the Docker images, and which will be instantly applied organization-wide. So, in order to make it more easier for the dev teams to use these scanners, we defined some kind of shared libraries for security tooling. So the purpose is to provide a high-level definition of what I want to provide as a scanning service. And this is actually the small piece of code that a dev team needs to add to its Jenkins file, for example, in order to run a statistics analysis using checkmarks. And this was something super easy because they don't have to worry about the configuration and stuff. And I think this is the foundation of Sec DevOps. We use DevOps tools in order to secure a DevOps process. And then we have the vulnerability management tools. So this layer will take care of the management of our issue, because simply when you have everything as critical, nothing is critical. So the vulnerability management tools will allow us to import results from different scanners, and they also got some nice functionality to handle false positive, like for example, false positive history. And then at some point, the scanning activity may generate a lot of logs. So you may, for example, want to dig into these logs to see, for example, why a scan was aborted and why this control was failed, or just you want to build your own metrics and visualization. So this is where the Elasticsearch stack come to the scene. So we used Elasticsearch to make some kind of SOC, but for application security. So the idea is to ship logs directly to Logstash, and then we can do any kind of normalization and we can normalize, we can filter, we can manipulate the risk value and use our custom risk metrics. And then we push result to Elasticsearch as a JSON data. And finally, we have some pre-built dashboard that will visualize our scanning results. So this is an example of visualization. It's basically used to track the risk over time. I'm just gonna quickly show you the interface. So this is the supervision interface. So at the left we have the SAST results, and then we have the DEST results. So the first graph is for monitoring or to track the issue over time. And then we have, for example, we can see what are the most vulnerable files identified during the scanning activities. We can also identify what are the the top 5 vulnerabilities that we have identified, etc. You also have the repository with a guideline to how to set up this framework. So I suggest you to fork this project and try it by yourself and submit issue if you have them. Okay, so so moving to a Docker ecosystem or an orchestration solution really helped us to resolve all the problems that we faced before, and as a result we had a scalable and high performance architecture that will help us to distribute the scanning workload through the whole cluster, and we have less tool to configure, and on the deployment server it's just the TLS mutual TLS authentication that you have to configure between the CI/CD engine and the Kubernetes clusters in order to use this framework. We still have few problems or enhancements, so all the Docker images are still heavy in terms of size, so we are planning to move everything to Alpine in order to optimize the memory resources. And also we want to explore more or build more visualization into the Elasticsearch stack in order to keep or track the scanning activity. So the next step, as I said, will be to explore more functionalities of Elasticsearch and enhance the fuzzing capabilities of our security testing tools and get more detailed logs. We also planning to customize our training program based on the results of the scanners, and also establish a solid knowledge base for secure code snippets. So that's it, and thanks you for your time.
We only have time for a couple questions.
Okay, this is pretty cool. I noticed that your process starts with Jenkins. So my question is, how you start the process with Jenkins? Do you have like a hook in the GitHub, so an engineer, when it pushes the code, it gets triggered and then evaluated, or how that works? How it requires like human interaction, or I missed that part.
So
yeah.
So I'm gonna just go through up.
I think it was like at the very beginning.
So we have defined the Groovy functions, for example, to run any kind of security scan. So you just have to put this 3 lines of code into your Jenkins file, and it can be run in parallel or even after a hook in GitLab. So you either have a choice to put this anywhere you like. So the idea is to have something, is portability. We don't have a specific configuration to run after a webhook or after a specific step.
So, okay, but how you avoid an engineer not putting that library in their code? Because in our case, for example, every time everything gets pushed into a GitHub, it will not get even evaluated by another engineer, so it will not get to master unless it passes the Jenkins test. Why? Do I make sense?
Are you talking about
so because
security gates?
Yeah, like an engineer will just like avoid putting this code because he knows that his code sucks. So how do you avoid that?
It depends on the solution you are using. For example, if you are using SonarQube, you can define what we call security proviso, which is related to security gates. And in the security gates, you can define, for example, if the risk score is, for example, high, we will stop the build. Okay, so it is really, it depends really on which environment are you using.
Okay, give it up for a speaker, please.